So this is 1.7 continued, and I really need to make sure I explain this because, well, you'll see this type of problem again, either on the test. I think it's on the test. So make sure you take good notes on this. And you go back and you reference it and make sure that you're good. Well, first of all, I need to give you the equation. So when we launch rockets from the ground, it's basically setting up the equation like this: y equals negative 16 t squared plus 112t. Now this negative 16 that's in front is representative of the gravity pulling the rocket back to Earth, and then this 112 represents the velocity. And there's some other math behind it, but you won't have to come up with this equation. I'll give you that equation. You don't have to stress about that. If you go open your book, it explains it if you're really that interested. So what you're doing is you're at a window that's 160 feet high, and it's asking you, so you're only looking straight out the window, you're not looking down. It's asking you in how many seconds will you see the rocket pass the window. So if you go to a calculator, and so this is the last thing you saw, let's just delete that out. And you were to write that equation, y equals negative 16, you can leave it as x, or you can make it t. The calculator is smart enough to know exactly what you're doing. Squared plus 100 and, I already forgot the number, 112 t. You need to zoom out. There's a button to the right here where I can zoom out. Now, unfortunately, it makes this graph really, really skinny. So I can change my settings. So I make my y really, really large, but my x-axis not that large. So maybe go from -1 to, I don't know, 10. There we go. So now my graph looks a lot prettier. And, all right, let's hide that. Now, because I'm at a height of 160 feet, so this is like me looking at the window, and this axis down here is representing time. So the first time it passes my window is at 2 seconds. So using a calculator, I can show then how many seconds it'll take 2 seconds to pass. Now, if you're curious, what you could do, because I haven't shown you how to solve this yet, is you can just guess and check. Make a t value and a y value. I like t because it's time. And just guess, okay, well at 0, what do you get for y? You get 0. When it's 1, what do you get? I don't know. I haven't figured that out. But at t equals 2, you'll get 160. So when will you see the rocket pass the window again? Well, let's go back to our calculator, because the rocket goes above, and again, we're looking straight out the window. So we won't see it again until t equals 5 seconds. So t equals 5 seconds. But again, if you're not comfortable with a graphing calculator or how to use it or Desmos, you can continue on with this table, 3, 4, and guess and check until you get this really nice answer of 160. So from firing, from the beginning, how many seconds does it take the rocket to hit the ground? So again, you can guess and check with these tables until we want to see when the rocket comes back to Earth, which it looks like at t equals 7 seconds. So I don't know what the value is at t equals 6. But back to this, t equals 7. Now you might be sitting there and saying, oh, Mr. Higby, I was thinking of a different way of doing this. I would say, okay, well, what are you thinking? And if you're saying, well, what if I went back to this, changed my settings to make it a table, and just started hitting, nope, didn't want to hit enter there. You got to go down here and start hitting enter. 3, 4, I guess it won't let me. I don't know what I did to mess up with the settings. 7 is look at this table and say, okay, 0, it's at 0. 1 is at 96 feet. 2, oh, that's what we're looking for, 160. So it's 2 is our answer. Next time was 5, hitting the ground at 7. That would work as well. You don't have to do problems my way. So the last question, approximate to the nearest tenth of a second when the rocket reaches its maximum height. because when you look at your graph, this is not the maximum. There's actually a higher value. And this graph is really nice. If you put your pointer right there, you can click and it'll actually tell you what the maximum height is. But if you go back to the question, so the maximum height is the y value, 196. The t value is 3.5 seconds. If you go back, it's approximating to the nearest second when, so the question's asking the time. And I think I showed you pretty clearly that it's 3.5 seconds. And then it asks approximately what the maximum height is. Now, I think it's safe to say we're giving the exact answer. The reason why they have the approximate is because if you're using a TI-84, you might just have to guess. But it's pretty clear that the answer is 196 feet. All right, so feel free to pause this video, go back, play with Desmos. That'll be much more beneficial for you than me telling you what buttons to push. And you should be ready for the homework now. So thank you for sticking with me and watching that last one. Again, it will help you on the test if you watch that video.